Uh, Welcome to the video, and today we are going to discuss another Leetcode daily challenge. Uh, Today is 26th June, and we are going to discuss this problem, which is maximum points you can obtain from cards. So let's first see what is the problem. So there are several cards arranged in a row, and each card has an associated number of points. The points are given in the integer array card points. Okay. In one step, you can take one card from the beginning or from the end of the row. You have to take exactly k cards. Okay. Your score is the sum of the points of the cards you have taken. Given the integer array card points and the integer k, return the maximum score you can obtain. So let me simplify the question for you. So let's head to the whiteboard. We are given n cards. So cards, let's denote cards by A, B, C, D till n. And there is a number which is associated with these numbers. So we have two for these. I'm taking random numbers here: 2, 4, 5, 3, and so on. So, and these are the points that are given to each card. Now, the thing is, and it is not an infinite, it is, these are n numbers, as we are talking about n total cards. So, in one operation, we can either take this card, which is at the starting of the array, or we can take the last card, which is at the end of the array. And we can only perform k operations, like we can only take out k, and we have to take it, sorry, we have to take out k cards. So it is compulsory, not less than or greater than exactly k cards we have to pick. And we have to find out, after picking those k cards and adding the points that are associated with those cards, what is the maximum sum that we can get. So I have two solutions for these. First, let's see a solution which is a recursive one. Okay, so before that, let's see what we can think of before going to jumping to that solution and how I came up with this solution. So the intuition is that every time in an array we have two choices: either to take this array, take this element which is at the starting, or take the end element which is at the end of the array. So there are always two choices. So there could be many different possibilities. Like first, like if we make decision tree, then first you have taken, like first you have taken A. Then after taking A, there are two choices for you. Either you can go for B or you can go for the last number. Let's denote it like uh, E, F, and G. So we can either go for B or we can go for G. So suppose if we go for B, then we have two options. We can go for C or we can go for G. And you can see that if suppose we are given k is equal to 3, so here k is equal to, now k left at this point will be equal to 2. Now only 2 cards are allowed from this stage. Here 3 cards were allowed to pick, and as we go down, the the k counter will decrease, and we will stop as soon as this k will become equal to 0. And that's how we will find out all the possibilities, and we will see which one is giving the maximum answer. Let's see how we can implement the recursive call. So let's take a function which returns void for now, and let's see the, let's say sum is the function name, and we want first we want a vector which is card points, and we also need mm, okay, so uh, we also need I, and we need j as two pointers. One is at the starting and one is at the end of it. And we can take sum. We can take s, which is the sum that we will calculate as we go forward and find out all the possibilities. Now, what will be the base case? So, if we go like we are moving I here, 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 and here, here, here. So it doesn't matter how we move I and j, because the only thing that matters is the pointer, the count k. You also need k. So if k is equal to 0, the answer will be updated. So we can either take the answer in the argument, or we can globally initiate or declare the answer. Uh, Globally declaring the answer is not a good way every time, but let's, for the sake of it, let's denote here. So it is 0 right now, and you go for maximum of a and s and the sum that we are calculating, and you return. Okay, now the next is what we have to do. We have two options, either to take the ith index element or the jth index element. Remember, the ith one is the starting, or the starting element, and the jth element in the vector is the last element. For the simplicity, we use it as v here. So let's see, taking element at the beginning, uh, beginning, beginning, uh, whatever, at the starting. Okay, so let's take the element at the starting. So we suppose we have taken that, we have vector. So if we have taken the first element, we will increment the ith pointer, jth pointer will remain as it is, and sum will be plus the element at the ith index. K will be -1. Find the next that we have is taking element at the end. So we can go for v. We are not incrementing I at all, we are decrementing j, and s plus equal to v plus vj, and we have k -1. So this is the answer. I guess this should work. Let's see, run it, and then we'll see if it works or not. I think it is going to give us the TLA at the final result, because we have 10 to the power 5 length, so it's going to be exponential, and it's going to be a large solution, so time complexity will be large. So I'm sure it is going to show TLE. I haven't implemented, I'm implementing it right now. Okay, so what we have to do is we have to find out. Let's first, okay, find out. We have to find out, we have to card points. We have 0, we have n minus 1. Let's declare n, which is n is equal to card points dot size. We have n minus n, we have s, which is equal to 0, and we have k. That's it. We return a and s. I think everything is good. Let's see if this works or not. Okay, so there is some problem with this solution. What is the problem? No matching function to call find. Okay, sorry. We are calling some. I used to call the find function usually, but I'm taking some. Okay, let's see. If this works, yeah, it is working pretty fine. Uh, like test cases are passing, but let's submit this and see how it goes. I'm sure it shows clearly. Okay, so memory limit exceeded. Okay, so it's not about time here, it's about memory limit exceeded. So either way, so time limit or memory limit exceeded, we are not going to do it because there are so many uh, calls that we are making here, A to B, and we are checking every possibility. So this is not a good solution. So let's see what I have thought of which is a much easier solution. And if you get this, you can do multiple problems which are related to this type of concept. So let's see that concept. Please pay attention right now. It is very important to understand. Once you understand this question, this solution, you will be able to do it pretty quickly next time. So, so let's forget this. We're not going to find out all the possibilities. Uh, so here the concept is, let's see what are the, let's take one simple test case. So let's take this test case. Let's see. Okay, so let's take 1 2 3 4 5 6 1. Okay, so we have 1, we have 2, we have 3, we have 4, we have 5 here, we have 6, and we have 1. Okay, now please pay attention. Remember that suppose I don't take any element from the left side. Okay, I'm not taking any element from the end, I'm just taking k elements from the right. So I can just move here and till k minus 1 index I can move and add all the elements and take them into consideration. Now suppose I don't go here and I only take elements from the end, k elements from the end, so I can just add them and get the answer. What is the next possibility that you can get? Okay, so the first that I told you is to just take all the elements from the beginning. So let's call this S1. Next is to take all the elements from the end. Let's consider them S2, k elements from the end. Now, there's also one possibility that you take x elements from here and y elements from here, which is equal to k. You get it? So I can take like if k is equal to 3, suppose if k is equal to 3, I can take suppose I've taken 2 elements here, I can't take more than 3 elements. Okay, so I've taken 2 elements here and I take 1 element here, which is 1 plus 2 plus 1, which is equal to S3. Get it? So there could be multiple combinations of x plus y, which is equal to k and which will give us some sum, and there could be S4, S5, so many of them, so many of the combinations could be possible. Uh, so we have to find out which one is the maximum, then we will find out which one is the maximum. So this is the intuition. So let's jump up to the solution and then I will there you will understand this intuition better. So for now let's move to the solution directly, and if you find it difficult or you don't understand it in one go, please rewind this video, replay it, and try to understand it. So here I have used a concept of prefix sum and suffix sum. So if you don't know prefix sum, let me tell you quickly. So if you have 1 2 3 4, you have 4 elements. What is the prefix sum? You take 1, you add to you you add this index, you add the previous number. So 2 plus 1 is equal to 3. Here you have 3, you add the previous number from this prefix array, which is 6. You have 4, you add this number and you get 10. So you're just adding the previous elements at every index. Okay. So this is the prefix sum, and for suffix sum you just move backwards. The same procedure, 4 will be copied, and then 4 plus 3, then whatever comes, then that to adding 2, and so on. So why are we taking this prefix sum? Let me show you what is the intuition. Okay, so if you go to some of the test case, like we have 1, we have 2, we have 3, we have 4, and we have 6, suppose. So we can take x elements from here, and x elements from here. You can take y elements from here, and you know that x plus y is equal to k. Uh, so what basically, when we are taking y elements, what basically we are doing, we are adding the points of these. Like if we have 2 elements, we add these, and if we are taking these k elements, they are contiguous, means they are continuous. There is no break. We are talking about sub arrays, not sub sequences. So they are going to be there will be no break. So, and that is what prefix and suffix sum is giving to us. At every index it gives us the sum till this index, from the beginning and from the end, and that is what we have to do. So let's see what we are doing here. So I've taken one prefix array and one suffix array, and n is equal to the size of the this prefix, and both will be the size of the array, the initial array. If k is greater than n, then we cannot do anything, we return 0, but that wouldn't be a case because we have to find out answer, or it could be a case. So for the safe side, we are initializing this, we are putting up this condition here. Now we are initializing, we are just finding out the prefix sum and the suffix sum for, so this, up to this code we have just found out the prefix sum and suffix sum. Now I've just reversed this suffix array, so that it could be easier for me to move in the array and find out the x and y. So I've taken -1, I is equal to -1, and I will go to k -1 till I plus plus, there till k -1, and I'm increasing that index I, and so this I is moving in prefix, and the j will be the left elements which are left, which are left after taking some of the elements in prefix. We'll find out how many elements or what is the value of y. So by taking I, we can find out how many elements we are taking as a prefix or from the beginning, which is x, and j is telling us the y, how many elements we can take from backwards. Okay, so we calculate j. I'm just doing j minus minus because it is required here for the index. So j will give me the direct index for the element, and I'm initializing two sums. One I will get from front. I can also include x or y, but just here. So a will give us the sum of the elements from taken from the starting, and b give us the elements that are taken from the back. So if I is greater than -1, so it means I am considering some elements in from the starting. Then I will add, then I will initialize a with the prefix of I. mm, like if I've taken like two elements, then here the prefix sum will be 3, 2 plus 1 3, so it will give me 3 because it has taken two elements here. Okay, similarly for b I will take it from backward for suffix, and I will add them, which is s, and then I will see which is the maximum value, answer or s, and I will keep on doing this uh, till k minus 1, and then I return the answer. So it is pretty confusing, but I think I've tried my best. Please go to the solution, try to dry run it, and try to see what I've told you previously, how what I'm considering x and y, and you will get. I hope you will get the intuition and the answer. And I've seen this type of solution 2 or 3 times till now, so I know that it is going to be a useful one for you. Let's run it once again so that uh, okay, so here we can run first with the sample test cases. Okay, it is running, then we submit it. Okay, so it is running pretty fine. Okay, so this was the solution. I hope you get it, and see you in the next video with another daily challenge. Take care.